Hello everyone, and I welcome you all to another video of our stack series, and this is going to be the last video of our stack, and we have learned fairly amount of stack and where to implement stack basically. And in this video we are going to look at a lead code hard problem, and after this you'd be like master in stack and would be able to do any stack question easily. Okay, so without any further ado, let's dive into the question. So given an array of integers height representing the histogram's bar height, where the width of each bar is 1, return the area of the largest rectangle in histogram. Okay. So let's go into our whiteboard and see what does it mean. Okay. So these are histograms of height 6, 2, 5, 4, 1, 5, and 6. Okay. Now we can make rectangles with it. Like we can make this rectangle. Okay. We can make this rectangle. Right. And we can make this rectangle. This one. Okay. What would be height of this rectangle? It was going to be 2 into width, which is 1, 2, 3, 4, 8. It is going to be 1, 1, 2, 3, 4, 5, 6, 7, 7. Okay. What about the area of this one? This is width 5 and width height is 5 and width is 2. So it is going to be what? 10. Okay, cool. So this is what it is. Okay. Now the question arises, how will you solve this question? Yeah. The first thing that comes in my mind is, suppose I take an element. Suppose I take 4 here. Okay. What I'm going to do is, I'm going to find its previous smaller, which is 2. And suppose it was not 1. It was something greater than, I suppose, 6. Okay, currently, and this is 2. So what will happen is, this would be the width for the left and this would be width for the right. Okay. And what I'll do, I'll just multiply the width, suppose W is the width, and I'll just multiply it with the height, which is 4, and I'll get the area. So I'll do this for every element, but suppose I'm at 6, so it doesn't have a previous smaller, so that's not an issue. I'll just put it as, I'll not operate on it, I'll just operate on the right one, and similarly I'll do other stuff. Okay. And what else I can do? Oh, okay, I guess that is enough for the logic. That logic would get us. Right. So let's clear it a bit again so we can have like more space. Yeah. Okay. Let's see the green then. So if I'm at, like, if I have to find the previous smaller and next smaller, what can I do? We have like learned about previous greater and next greater in our previous videos. We make it using our stack, so we are going to use a stack to make previous smaller array and next smaller array, and for every element we'll find the width using these two and multiply it with the area, with the number of that index element. Okay, and which is the maximum, we'll just multiply it. Okay, I guess you understood what we are trying to do here. Okay, that's a very basic approach. Now the thing is, I want to do it one single loop. Like for previous smaller, I have to make one loop. For next smaller, I have to make another loop. But what if I want to have a single loop only? I have to work on a single loop. How can we do that? Well, we are first trying to code it, and I'll teach you it side by side, so you can understand it better. Okay. So we have talked that we are going to use a stack, right? So let's make a stack of int s, and let's have int n, which is going to be heights.size. Okay, and we have our int res, which will store our, obviously, maximum value. And what else, what else? I guess that's it for the variables. Now I'm simply going to traverse. I'll say while not s dot empty and heights s dot top greater than equal to heights I. I'll have a int tp as s dot top and I'll simply s dot pop. So what is happening here is, see, I'm going to create a stack and what I'm going to, for every I, I'm trying to find the previous smaller of it, right? We can find it using this way. Suppose if the height of our top element is greater, so we'll remove it, we'll remove it till the top element is smaller than our ith element. Okay. Now what will happen to this top element? So if I remove a top element, its previous smaller would be the new top element of the stack. Okay, that makes sense. And suppose if I removed it, that means the ith element is smaller than it. So that means its next element is our ith element. Yeah. So that is how we are going to find the next smaller and previous smaller in one go. So in our int answer, we'll simply write if suppose if s was empty. So I won't have its previous smaller, so I'll just have I as width. Otherwise, I'll have the width as I minus s dot top minus 1 and we'll simply multiply it with heights I. Yeah, okay, that makes sense. And then in res, I'll just put max of either res or answer. Okay, and in the end, I'll just s push I. Cool. So this makes perfect sense. Now we have like, okay, let me take a situation. Let's use a different pen. Okay, this one doesn't look good, right? Let's take it to our basic. Let's take the red one. Yeah. Suppose this was our stack, right? And suppose here it was 2 and here it was 4. Okay, and now we have 1 here. It was 1 5. Okay, we'll just keep it 1 5. So we have 1 5 here. So now we are at 1. So for 1, we'll pop out 4. Is that correct? Yeah. Could be empty for 1. We popped out 4 for 4. Its next smaller is 2 and its previous smaller is 2 and its next smaller is going to be the 1, right? Okay, cool. So I'll just compute that thing which I already did in the code, so you'll understand it. But what I'm trying to say is now for 1, 2 is also smaller, so I'll remove the 2 part. Okay. Now I'll have 1 here in this stack. Now I'll come at 5. 5's what would be 5's? I'll insert 5 also, right? I'll insert 6 as well. So what is happening here is that these elements 1, 5, 6, they don't have any next smaller, right? You can see 1 don't have any smaller, 5 don't have any smaller, and 6 obviously don't have any smaller. So how we can solve for these? We can easily solve by using its previous smaller. For 6, we find a previous smaller. For 5, we are going to do a previous smaller, and for 1, we are going to do a previous smaller. So for 6, previous smaller, if we have to solve, uh, its previous smaller is going to be 5, obviously. For 5, it is going to be 1, obviously. And for 1, since it is empty, the whole thing would be the width. Alright. So let's try and write that code as well. So I'll just simply write while s dot empty. I'm going to write int tp or Yeah, we'll call it s dot push s dot top. Sorry, my bad. S dot top. We'll remove the top element. Right. And now our answer is going to have depends on s dot empty. Suppose if s is empty, we'll have with us n. Otherwise, we are going to have with us n minus s dot tau minus 1, right? And we'll multiply it with heights of t. Okay, and res is going to be max of res comma answer, and in the end I'll simply return our res. Okay, now let's try and run this code. Hope this thing works. I'm getting a wrong output. What is the problem? Let's see what exactly we are doing wrong here. For int I is equal to 0, I less than I plus plus, while not is empty, and height of s dot top. Okay, this is correct. TP we are storing as dot top, and we are removing it, and in the answer it is I, and I minus s dot top minus 1 into heights of, okay, this is going to be heights of TP, right? And then res is going to be max of either res and answer, and I'll simply going to push it. Now I'll saying while not is that empty, TP is going to be s dot top, okay, s dot pop, and in the answer we are going to have either if s is empty we are going to have n, otherwise n minus s dot top minus 1 into heights TP, and res is max of res and answer, and in the end we are simply returning answer. Okay, I don't think we have any problem here as such. Okay, so that was the only error. Now let's try and submit this. It works. Okay, it works. Sounds cool. Okay, so we have solved a very hard question of our lead code and based on stack. So I hope you guys get the fair idea of stack and how to use it. And from the next video, we are going to look at another data structure, which would be probably Q, or else you'll know it when we are going to start it. Okay. And if you have any doubt regarding this video and algorithm, just comment it down in the comment section. I look at it. And thank you for watching and stay tuned for more videos.